We'll take a couple of questions from the audience and also from the virtual attendees. I can start with a question that I received. And this is for a panel. Let one of the members or more than one answer. How will Composite's implementation and demonstration projects be affected by the newly passed transportation infrastructure bill? What's their perspective? I know. Like to know. Yep.
So I think there's a lot of opportunity.
Yep, the press the button.
Go ahead. Okay. I think there's a tremendous amount of opportunity. I mentioned that there's funding going into all 17 categories of the ASCE infrastructure report card. There's a lot of grant money out there. There's hundreds of billions of dollars being deployed for construction projects that would happen in all the states that we've talked about. And then there are tens of billions of dollars for R&D. So, and we're talking billions here, not millions, hundreds of millions of dollars for construction projects and tens of billions of dollars for R&D. Just some areas that I think are really ripe for benefiting from the report from the infrastructure bill. I think FRP rebar is going to take off. You're already seeing more and more states. I talked about Florida using it. Joe just talked about Maine using it. I know the state of Ohio is really bullish on using FRP rebar. And I also think, sadly, in light of the condominium complex or collapse that happened in Florida last year, I think you're going to see a lot more FRP rebar used in buildings, because I think we've all seen the pictures of the corroded rebar and the spalled concrete underneath that condominium. So I think FRP rebar is going to really have a surge here with the infrastructure money. I think seawalls. I think everything that's happening with sea level rise is happening all around the country. I think seawalls are going to happen. And I think pedestrian bridges and those cantilever sidewalks that John and I talked about, you may not be refurbishing the entire bridge with composites, but that's something that the DOT wants. That's something that people want. They want to be able to walk across bridges. They want to be able to ride across bridges. It's lightweight addition. It's not going to cost as much money as replacing the entire bridge. I think that's another opportunity.
Thanks, Joe. Any other comments? Yep.
So, hello, there we go. One of the challenges is going to be, there's a lot of funding that is in the bill. There's a lot of programs that are in the bill. The state DOTs need to take the lead role and collaborating, and I use that in my presentation, and collaborating with industry to integrate and implement those products with those programs in place. So select your dance partner and dance well with them, because they're going to be your best friend. With that said, I think one of the challenges is going to be, and I don't necessarily know how that's going to play out, sustainability is been talked about and mentioned. And as an industry, we're going to have answers to that sustainability question, because the owners are going to be asking, and they're going to be asked to report on what the sustainability decisions are going to be. So I think we have homework to do. It's good to see a long-term bill. We haven't seen that in a while. I think there's funds in place. And I think it's a matter of how the asset owners are going to make their priorities and their decisions.
Good. Yep, we have a question. Go ahead. You want to stand up so we can all hear? Thanks.
Do you think there's any chance that FRP could be used to replace the
Anyone would like to take that question?
Other than polymer concrete? No.
Mhm.
But polymer concrete, yes.
Okay.
Which is a wearing surface, right?
Okay, thanks, John. I have a question here from a virtual attendee. Can the speakers comment about long-time creep and stress relaxation of FRP materials? So this is a good technical question. Anyone would like to comment? Yeah.
I think that'll be part of this afternoon's discussion. I know there's an ongoing evaluation of fatigue and creep at the TIDC for girders similar to the ones that were done in Twin Bridge.
You know, maybe not necessarily in transportation structures, and we kind of see that already. You know, when we design, we don't design to maximum strains. So as long as we keep the strains low.
Yep.
Where we have the high strength, but the strains are low, we're not going to see that creep. So part of it is, you know, what are the safety factors that are used to allow for that safe implementation and design? And we're always wanting to push the envelope. So if you look at a lot of the structures that are in the corrosion industry, and Joe pointed out to what is done in mining and pharmaceuticals and what have you, these are huge structures. There is no doubt. The safety factors are a little bit on the high side. I think over the years, there's been an evolution to refining, retooling, you know, understanding the application. But I think part of it is keeping the strains low.
Thanks, John. I would like to add that composites, as we know, are made of more than one material. We have polymers and fibers. And to be able to prevent these long-term effects like creep, what is key here is to have continuous fibers. That those are the ones that do not exhibit any significant creep. Therefore, this question is really timely because it points to the need of rational designs. I mean, designing with composites requires that extra knowledge, that understanding of how the material behaves. And a well-done design based on fundamentals, it will prevent any significant creep. And the approach that John mentioned is probably the right one by limiting the deflections that the material will see during service. Any other questions? Yes. Do you want to stand up? If you don't mind, thanks.
Yeah, I'm a geotechnical engineer, so.
Yeah.
But I see a lot of bridge repair, the bridge decks, like the joints, the expansion joints, and those sort of things are not quite corrosion related. Is there an application for FRP for composites that are not corrosion? I'm not sure if that's what there's a role for composites in that application.
You mean applications in geotechnical engineer or?
At the bridge joints, at the decks where the, where there's a lot of maintenance and repair I see going on. Wherever I travel.
Good.
The repairs at the joints and everything is what we call an old detail. I know that BANOT Bridge program, the last couple of years, probably last 5 or 10 years, has made a huge effort to eliminate all bridge joints we can using different technologies and approaches. But where they are available, you kind of run into with the joints themselves. Composites are great, but the carbide blade of a snowplow is that much more powerful. So we just cut them in half. So that's where steel's resiliency on those go. But there is composites, downspouts that we're putting underneath the joints to try and mitigate things through better engineering practices, and detailing is the bigger one for joints themselves.
Great, thanks, Joe. Any other questions from the audience? Or from the virtual attendees? No, okay. Well, we are past time and lunch is ready. So thanks very much to our presenters who have served in the panel, and everyone for your attendance.